We're going to be covering special right triangles. Special right triangles. In your online textbook, this is covered in pages 400 to 408. 400 to 408. Please turn off all electronic distractions. Also, please record the location you are watching this video as well as the date and time. The date and time. Let's first review the previous lesson. In the previous lesson, let's look at what we have and need and what we should do. We have here a right triangle with an altitude. We have a right triangle with an altitude. And what we need, X would be considered the long leg, Y is the altitude itself, and Z is the short leg. So what allows us to work with long legs, short legs, and altitudes? And in this case, we're going to use geometric means. Since we have three variables, we're going to be working with three different scenarios. First off, let's label what we have. Our Z here is going to be our short leg. So I'm just going to use the abbreviation SL. And our X is going to be our long leg, so I'm going to do LL. Our Y is our altitude. 12, the entire thing, is our hypo. 8 is going to be considered the long segment, so we're going to use LS. And then what we don't know here, that's going to be our short segment, so we're going to do SS. So now we have labeled everything that we can label. We have three different variables, so we're going to work with potentially three different geometric means. So let's set up our means here. We're going to solve for X, Y, and Z. Let's try X first. X is the long leg. So we come over here to our geometric means and we notice that the long leg is the geometric mean between the long segment and the hypo. So let's write out that equation. The long leg is the geometric mean between the long segment and the hypo. That is going to give us X, because X in this case is the long leg. Let's take a look at Y. Y is the altitude. So we know here in this one that the altitude is the geometric mean between the short segment and the long segment. This will give us Y. And Z is our short leg, and we know our short leg is our geometric mean between the short segment and the hypotenuse. So using these three scenarios, we're going to solve for X, Y, and Z. So solving for X. X is the geometric mean between the long segment and the hypo. So we're going to use our X here, which is our long leg, and our long segment is 8, and our hypo is 12. We cross multiply. We're going to end up with X times X, which is X squared, equals 8 times 12. Of course, we square root both sides. I'm going to go ahead and factor and pull out my pairs. I know this is 2 times 4, and this is 3 times 4. That's 8 and 12. I have a pair of 4s. 4s, so you have a pair of them come out on the outside. So my final answer for x equals 4 root, then 2 times 3 is 6. 4 root 6. For y, my short segment. Well, I don't have my short segment, but what I do know is if this whole thing is 12 and this is 8, I can find my short segment, 12 minus 8, so that means this, of course, is 4. So my short segment here is 4 over my altitude, which I don't know, and we're calling y, equals my altitude y over my long segment, which is 8. So we get y times y, which is y squared, equals 4 times 8. The square root both sides. This is 4 times 4 times 2. 4s are a pair, they come out. So y equals 4 square root of 2. Last one, we're going to solve for z. Z is our short leg, which is the geometric mean between the short segment and the hypo. So our short segment we already figured out is 4. Short leg we don't know, we're calling it z, but our hypo is 12. So we have z times z, which is z squared, 4 times 12. Square root both sides. Z equals square root, and we have 4, and then we have 4 again times 3. Double 4s come out, so z is going to equal 4 square root of 3. 4 square root of 3. That's called geometric means. Now we're going to talk about something called special right triangles. This is an absolutely critical lesson for future math classes, especially trigonometry. So we have here, we've learned the Pythagorean theorem and geometric mean. In the 30, 60, 90, we have two special right triangles. They are the 30, 60, 90 triangle and the 45, 45, 90. They are special circumstances, special triangles. They have a pattern to them that you should be familiar with. Let's try the 30, 60, 90 triangles first. Let's try using the Pythagorean theorem. Here's a 90 degrees, here's 30, here's 60. We have here one leg is 5, the other leg is 5 root 3, and unknown. So we're going to solve using the Pythagorean theorem. 5 times 5 is 25. 5 root 3 squared looks like this. 5 root 3 times 5 root 3. Outies, 25. Innies times 3 equals 75. So this is 75 equals x squared. 100 equals x squared. You square root both sides. X equals 10. Here's another scenario. Let's say we have a side here that's 9, an unknown side that's x, and our hypo is 6 root 3. We're going to solve using x squared plus 9 squared equals 6 root 3 squared. This is x squared. This is 81. 6 root 3 times 6 root 3 looks like this. Outies, 36. Innies times 3. That's going to be 108. Subtract 81 both sides. You get 27. We're going to square root. 9 times 3. 9's perfect, gets out of jail, has a change of heart, so our unknown side here is going to be 3 root 3. Now, there is a pattern in both triangles, a very important pattern. The pattern you should see here is that between the short leg and the hypo, we're timesing by 2. Between the short leg and the long leg, we're timesing by root 3. Again, between the short leg and the hypo, you times by 2. The short leg to the long leg, you times by root 3. That is the pattern for every 30, 60, 90 triangle. Let's show this here. In any 30, 60, 90 triangle, we're going to label. Here's your hypo, put an H. Across from the 30 degrees is going to be our short leg, and across from the 60 is going to be our long leg. And the pattern is this. Whatever the short leg is, to get the hypo, we times by 2. Whatever the short leg is, to get the long leg, we times by root 3. Another way to show this is whatever the short leg is, to get the hypo, you times by 2. But to get the long leg, you times by root 3. This is the pattern only in 30, 60, 90 triangles. Let me show you how to actually use this. So here we have a triangle, and 3 is our short leg. So we're just going to write SL here. To get the hypo, we have to times by 2. But to get our long leg, we have to times by root 3. So if our short leg, long leg, hypo, if our short leg is 3, if we times by 2, our hypo must be 6. And our long leg, if we times by root 3, our long leg is simply going to be 3 root 3. So in this scenario, x is going to be 6, and our long leg is going to be 3 root 3. Let's try another one. Again, we have a 30, 60, 90 triangle. The pattern is this in a 30, 60, 90 triangle. Short leg, long leg, hypo. Whatever the short leg is, we times by 2 to get the hypo. So the hypo is 2 times the short leg. Whatever the short leg is, we times by root 3 to get the long leg. So the short leg is the long leg is the short leg times by root 3. That's the pattern in a 30, 60, 90 triangle only. So we look here and we see 3. We have to label here. 3 is in the long leg position. This is short leg and hypo. We know to get the short leg to the long leg, we have to times by root 3. So we ask ourselves, what times root 3 gave us 3? Whatever that what is going to be our short leg. We learned in a previous lesson that any radical times itself is just the radical inside. So our blank here is simply going to be root 3. So our short leg is root 3. Our long leg, we times by 2. So our hypo, is going to be 2 root 3. Using this table, without using a calculator, I'd like you to solve for the unknowns v and u, please. Without using a calculator, solve for the unknowns v and u. Okay, let's label first. This is our hypo. This is our short leg, and across from the 60 is going to be our long leg. So let's pull out our table. Short leg, long leg, hypo. We are given 4 root 3 in the long leg position. Well, we see right here that the long leg is whatever the short leg was times root 3. So we ask ourselves, something times root 3 is 4 root 3. That should be pretty obvious. Our something here is simply 4. So our short leg is 4. And our hypo is 2 times the short leg. So 2 times 4, our unknown is 8. So V is 4 and U is 8. That is the 30, 60, 90 table. Now in the 45, 45, 90 triangle, there is a different pattern. There is a different pattern. In a 45, 45, 90 table, it's actually easier. The pattern is this. Since we have 2 equal angles, if you follow the hatch marks, it implies that you have 2 equal sides. So that's the first pattern. 2 equal angles imply 2 equal sides. The second pattern is this. Whatever the sides are, we'll call it n here. To get the hypo, you times by root 2. Not 2, root 2. That's for a 45, 45, 90 table. So we want to write this out. When you have a 45, 45, 90 triangle, the legs are equal. So we write leg equal leg. The hypo is going to be whatever either leg is, which will be the same, and we're going to times by root 2. That is the hypo. So the hypo equals whatever the leg is times root 2. Let me give you an example. Find our missing lengths. We have a 45, 45, 90 triangle. Here's our table. Leg, leg, hypo. Whatever the legs are, they are equal. And the hypo is whatever the leg is times root 2. So if this leg is 3, this leg over here is automatically 3. And then you simply times by root 2, so y here, which is our hypo, is going to be 3 root 2. And you're done. Let's do another example. Let's recopy our table. This is a 45, 45, 90. Leg, leg, hypo. Whatever the leg is, they are equal. Because this is an isosceles right triangle, the hypo is whatever the leg is times root 2. So let's see what we actually have here. We have 10. Now this gets a little bit trickier because you have to ask yourself, what times root 2 is 10. Let's write this out. What something times root 2 is 10. Why? Because 10's our hypo. And the hypo is whatever the leg is times root 2. The problem here is we don't know the leg this time, so we're having to work backwards. So something times root 2 is 10. Let's think of this logically. We have to get rid of the root 2, obviously, so we need another root 2 here. So root 2 times root 2 just gives us 2. Now ask yourself, what times 2 is 10? What times 2 is 10? The answer is 5. So our complete answer for x and y is 5 root 2. Because the legs are equal. I'd like you to pause the video now and do this problem on your own. The hypotenuse is 6. Find both legs. Pause the video. Without a calculator, find both legs. Okay, let's see what happened here. In a 45-45, the legs are equal. So whatever these are, x and y, we know they're equal. The hypo is whatever the leg was times root 2. Whatever this was times root 2 gave us that. So let's write it like this. Something times root 2 is 6. You have to ask yourself, what is that something? Well, first to get rid of the radical, we need a root 2, because root 2 times root 2 is 2. Now ask yourself this, what times 2 is 6? And the answer is 3. So our something is going to be 3 root 2. 3 root 2. For both, because the legs are equal. So here are the two tables that are absolutely critical that you memorize. In a 45-45-90 table, the legs are going to be equal, and the hypo is whatever a leg is times the square root of 2. In a 30-60-90 table, we have the short leg. The hypo is 2 times the short leg. And the long leg is the short leg times root 3. Very critical that you absolutely memorize both tables. Again, when do you use them? For a 45-45-90 triangle and a 30-60-90 triangle.